All right, how do I find the measures of angles inside or outside a circle? It's a very fancy essential question today. How do I find the measures of angles inside or outside a circle? We only have 3 theorems and then 3 examples. The reason why it's 4 pages is because of the circles, okay? So if you make the circle smaller, obviously it'll take up less room, but we're drawing lots of circles. There's like 3, 6, 7, 8 circles, okay? All right, so theorem 10.11. Theorem 10.11. It says, if a tangent, what's a tangent? What's a tangent? What's a tangent? Longer, oh, we're going to be here forever. You should know that. If a tangent and a chord, what's a chord? Not going to pass on Monday.
She said thank you and then she'll talk to you later.
Wow. 2 dots does not help us.
2 points on the inside of the circle.
It's a segment that has both endpoints on the circle. So if a chord and a tangent intersect, what does it mean to intersect? Cross or meet at a point in a circle, then the measure of each angle formed is half the measure of its intercepted arc. If a tangent and a chord intersect at a point in a circle, then the measure of each angle formed is half the measure of its intercepted arc. God bless you. Kind of sounds like inscribed angle, yes? Yeah, it should be. What does it mean to be an intercepted arc? I think you guys might have to have homework that's like make flashcards. Oops. What's it mean to be an intercepted arc? Lies in the interior of what? Of the angle. Ladies and gentlemen, let's think about this. When you have, we're going to pretend we have like Pac-Man, yes? When you have your Pac-Man, yes? Make sense? Let's pretend we're looking at angle 2. Bless you. This Pac-Man is eating this way, correct? Intercepted angles in inside. This angle goes this way, so the Pac-Man has a smaller piece, yes? That's what the intercepted arc means. It's inside of the angle. When the angle opens up, it's connected inside. Make sense? Okay. So, you need to know what these mean, because you're going to be like, I don't know. You just see these pictures and then get stuck. So what this says, it says that if a tangent and a chord, here's your tangent, here's your chord, intersect at a point, they're intersecting at point A, correct? Okay. Then the measure of each angle. So the measure of angle 1, just watch, equals, right? So the measure of each angle formed, there's 2 angles, 1 and 2. That's all the angles there are, there's only 2. Is half the measure of its intercepted arc. So if I'm looking at angle 1, what is its arc? Arc what? measure of arc AB. And it says half, so we have to divide by 2. Okay? Easier to divide by 2 than multiply by 1/2 for some of you. 90% of you, it's easier that way. For some of you, you know how to multiply by 1/2.
Can I pay you right now?
All right. So let's look at the measure. You know there's one right there. Let's look at the second one. It says the measure of angle 2 equals. What do you think the arc is named? BCA. So the measure of arc, BCA, divided by 2. Doesn't that look really similar to an intercepted arc? Or inscribed angle, sorry. Inscribed angle, right? The only difference is now we have these like lovely little things on the outside because we have a tangent. But it's almost the same thing. It's saying you have an angle and the arc is bigger than the angle by 2. Okay? All right. Let's talk about, this is a fancy word, guys. Angles inside the circle. Theorem. I know it's so fancy. Angles inside the theorem. Angles inside the circle theorem. Oh Lord, let me take this. It stinks. It smells in here. That's kind of gross, but okay. All right. It says, if 2 chords, what does it mean to be a chord again? What is it? It's not a line. It's a segment that where? Both endpoints are on the circle. Does it have to go through the center? Can it go through the center? Yes. All right, intersect. Inside a circle. Am I telling you where they intersect? Just inside. Do I care exactly where? No. Does it have to be the center? No. Do you think it's going to be the center at all? No, probably not. Okay? Otherwise, we have central angles at that point. So it says 2 chords intersect inside a circle. Then, the measure of each angle is half the sum. Oh, what does it mean to be a sum? Addition means you're adding. Of the measures of the arcs intercepted by the angle and its vertical angle. I'll let you write that. Ready? Okay. Draw a picture and see what this is talking about. Circle. Chord. AC. Chord. BD. Angle 1. Alright, here we go. Let's read what it says and do this problem. It says, if two chords intersect, or do we have two chords intersecting? Okay. Then the measure of each angle is half the sum of the measures of the intercepted arcs and its vertical angle. So watch. Here's my angle, angle 1. Yes? Its intercepted arc is what? Arc what? Where is the Pac-Man eating? BC. Yes? Here's your angle. It's eating that arc over there. Okay. And its vertical angle. What does it mean to be a vertical angle? Across from it. Now, they're not necessarily congruent. Do you hear me? They can be congruent when you're in the center, because everything's pretty in the center. But right now, you're not in the center, so they're not going to be congruent. Do you understand? Vertical angle just means it's across from it. So across is what arc? A what? AD. AB is next to it. AD is across from it. So this is what it says. If two chords intersect inside a circle, done. Then the measure of each angle, here's the angle, is half the sum of this arc and its vertical arc. Okay? So I'm going to write it. And it's going to say the measure of angle 1 equals the measure of arc BC plus the measure of arc AD divided by what? 2. Keyword in this problem, sum, half, inside. You should know that sum goes with inside. Okay? So, if I go ahead and call this angle 2 right here, I want you to write the formula for angle 2. I'll start you off. The measure of angle 2 equals. Fill out the other side. Do you write it? What did you write? The measure of arc CD plus measure of arc AB divided by 2. Good. Okay? All right. Let's keep going. Okay, we did angles inside. Now we need to do angles outside. Angles outside the circle theorem. it says, if a tangent and a secant. What's a secant? We just went over tangent. Tangent touches the circle how many times? Once. What's a secant? Touches it twice, okay? So if a tangent and a secant, comma, two tangents, comma, or two secants, intersect outside a circle then the measure of the angle formed is half if inside was sum, outside's probably difference. It's half the difference. What does difference mean? Subtraction of the measures of the intercepted arcs. Good? Okay. It says, if you have a tangent and a secant, or you have what? Two tangents, or you have what? Two secants. So we're going to draw all three so we can see them all. Okay? So we're going to start with the first one. So what's the first one say? Tangent and secant. Let's give me number one. Oops. Okay, this is the tangent and a secant, correct? Okay. Ready? Oh wait, something's so dry. Oh my goodness gracious. Ready? Okay. So what it says is this. It says the measure of the angle formed. So the measure of angle 1 is equal to half the difference of the measures of its intercepted arcs. So what is the first arc? Now, ladies and gentlemen, the thing with this one is you have to be careful. It's always is this bigger than this one? BD is bigger, right? So it's always big minus small because it's difference. And if you're doing small minus big, you end up with what kind of number? A negative. And can you have a negative angle? No. So you always need to remember it's big minus small. Okay? So the measure of angle 1 equals, what's the big arc? The measure of arc what? BD. Difference means what? Subtracting. What are we subtracting? Measure of arc AD divided by 2. So does it look very similar to the other side? Yeah. The difference with the other side, you were adding, but you were inside. Now you're outside, so you're subtracting. Okay? What's our second scenario? 2 tangents. So let's draw it. Now what? Does it say anything different? Or does it say the exact same thing? Is the theorem changing? It is? The theorem's not changing. It's still saying the same thing, right? So what do you think it's going to say? The measure of angle T equals what? Measure of arc? PQR. Minus measure of arc? PR. All divided by 2. Yes? Theorem's the same. The only thing is I changed the letters to make it look different. It's exactly the same, yes? Okay, what's our next picture? 2 secants. All right. That one's easy to draw. See if you can write the formula by yourself. Start you off. Measure of angle 3 equals. All right, what do we do? Measure of angle 3 equals what? Measure of arc what? XY. Minus what, Anthony? WZ, all divided by what? 2. Good? Questions? All right, let's do examples. All right, find the measure of arc DFE. DFE. Who has an answer? 2 of you. What do you think it is, guys? What are we doing? The measure of angle what? Give it a letter, a number. Can we say 1? Equals, what's the arc we're looking at? DFE, the measure of arc DFE over 2. Do you know the measure of angle 1? How much is it? 117. Do you know the arc? No, so what do you call something you don't know? X over 2. How do you solve this? Multiply by 2. So x equals what? 234. So the measure of arc DFE is equal to what? 234 degrees. Who had it right? How many of you used to do puzzles when you were little? Guess what this is? It's a puzzle. You have to be able to look at things, guys. It's not very explicit. Finding measures, again. See if you can do this one. J, M, O, K, X degrees, 156 degrees, 130 degrees. Try it. Ready? Who has an answer? Good. Who highlighted? That may have helped some of you. If the angle's here, what's the arc I'm looking at? Arc KO and arc JM. Yes? Okay. You should have started the measure of angle 1, give it a number, equals what? No, let's write it out first so people can see. The measure of arc what? KO plus, very good, the measure of arc JM, Jamie's going to pick up her head, divided by what? 2. Jamie. Do we know the measure? Oops, I shouldn't have put measure of angle 1. Do we know the measure of angle 1? What do you want to call it? Good. Equals, what's KO? plus divided by, what's 156 and 130? 286. Divided by 2 is what? 143. Got it right. Good. Last one. Find the value of A. Find the value of A. Oh, it's a little bit of egg. Let's see if you can do it. Check with somebody. Check with somebody. Ready? Who has an answer? Check with somebody next to you. I don't care if they didn't do it, they need to learn how to set it up. Ready? Ready? The measured angle 1 equals, it doesn't matter if you call it 1, 2, or 3, it doesn't really matter. I'm just going to call it 1. Some of you may have called it 3. Measured angle 1 equals what? Measure of arc FG, the big one minus? Very good, the small one, divided by? 2. Good. What did you plug in for measure of angle 1? 30 equals x or a minus 44 all over 2. How do you get rid of the 2? Multiply by 2 on the top and the, Or, just kidding, on both sides. Yeah. That cancels out, yes? Okay, so what do we got on this side? 60 equals a minus 44. What do you do? Add 44 and a equals 104. No degrees, just 104. When it wants to an angle or an arc, then you put the degrees. When it says find the value of the variable, it's just a number. Got it right. Good. And then we got stuck with the 2 on the bottom. It's not that bad though, right? Okay. Homework. You actually have a little bit of homework time. I know. Shocker. Oh, guess where it's located? In the geometry book. Page 6. Yeah, he did. 683. Numbers 3 through 5. 7 through 12. And then you're going to do on the same page, 686. Numbers 1 through 6. That part's a review. Why do you think you have a review? Because you have a quiz on Monday. Good? Get to working.